review of the circuit. Let me show you this one because this is how I started originally, and this was the main building circuit that I looked at and that it guided me. But like I put a title here, old and bad circuit. It's not that bad. Well, yeah, it's bad, but it was the building circuit that I started with, and this was the idea when I was formulating the idea, what I wanted to look like, how it should look like, how it should feel like, how the circuit should be, how to position things, etc., etc. You know, those little fucking problems that you have to deal with when you design such stuff. And after I finished building it, I discovered I make some mistakes. The mistakes are you see that I slapped these values without thinking actually what is really going on here on these pads. Although I was having the circuit diagram in front of me, I was following it. But for some reason, these three resistors are wrong here, the position. This 1 kilo should have been linked to negative here because this is how I tested originally on the breadboard. And I noted on my paper there. And these two values should have been placed to the right here to the positive rail. So this is the first mistake with position of these resistors. And because the position is changed, this wire here that is coming from the positive, you see here from the positive input, should be more longer to match. And you will see it here in the good circuit that I changed it after I discovered the problems, after I built everything, after I corrected all the little details that I didn't manage to foresee them from the first model here, from this old and bad one, which is not that bad, but yeah. So this is and here are the actual values of the resistors that I used in reality. And this, by the way, the values that you are seeing on these resistors here in my 3D view that you are watching right now are not the resistor value, the SMD resistor value that is written on it. Is actually the resistive value of the component. So when you are seeing here 680, it means 680 ohms, and in total 680 plus 130 means this 810 ohms. It is not 68 ohms because 680 means 68 ohms, not 680. I know it's a bit confusing from this perspective. I pinned this little detail in my head to mention it here when I will present this 3D view. But it's how I get used to put the values. Probably I should put the actual value of, but it's simple for me to visualize it like this, and probably they should use this simple notation. So these are the actual order of the resistor, and as you can see, the length of this wire is also corrected here because this was giving me some serious troubles before. After I changed the resistor, I forgot to change the wires, and then I realized, the logic is inverse. And also here, this is a very tiny little detail. So this is the order that you are seeing it here mentioned, like you see this 1, 2, 3, and 4, and then it's connecting correctly here. This is in order here. This is the actual order on the LEDs, 1, 2, 3, 4. And also I changed. Originally I used 1 kilo here. Probably I still have it here on the bed. I don't even have that resistor here. That was another mistake that I catch it in time. Fortunately, when I was building, I was asking myself, if I'm dragging this positive wire directly to the LEDs, will they not be burnt? And then I looked on the schematic. Then I compared the schematic circuit with the 3D view that I'm having here, and I slapped my arm. And I realized I forgot. I totally forgot to add this little resistor here, and I made another pad for it, and then I built it correctly on the cardboard that you've seen me there. But I catch it on while I was making it. You know, when it's all together like it is here, especially the yellow layer here. This is the yellow layer that is going underneath. Do you see how? Let me select probably that one. Yeah, you see, it's going under. It's on under the cardboard. So it's showing it here, but it's not that visible. It's kind of showing it. Yeah, you see, is these two large pads. So it's this pad here and this pad here, and these two large pads are literally under the cardboard, and their respective wires, this yellow wire, are linked to the negative. So because this is too much wiring here and a bit crazy, I separated in 2 layers. So this yellow layer, this is the layer that is going under the board, beneath the board, and this is on top of the board pretty much. So that's what I did here. What is from the same circuit that you are seeing here, nothing special. And this, if you want, this is another layer that is coming on the top with the LEDs. I didn't put this 30, 40, 50, and 60 notations on my cardboard there, but it is mentioned. I should put them, and I leave a lot of space for any writing. Future writing that I should add in the future. And this is the box actually that is going on top of that. You see, you can see it here, full ensembled, how it will look. You know, I even designed this part here, how it should, the sensor element, how it should look. It greatly helped me. how to visualize everything. All right, that's it for this part. So I hope you enjoyed my little 3D view here. Here I'm looking on this screen, on my 3D view, and I'm basically copying it. So this right side here is already made. Now the left side. Do you see how easy and pleasant it is to make it? It's very easy, very, very easy. Intimate detail is that this side is down compared with this side, which is a little bit higher. You see, this is aligned with this first pin here, while this one are aligned with the third one. But the idea is that this is up a little bit and this is down a little bit, and it will show this little décalage. It will show here as well. Let's work. No talking, more working. This is the Chinese word of the day when they are starting the day. All right, so I changed a little bit. 1, 2, 3, 4. This fourth one, or the first one, actually, I elongated. I made it long as that one. I changed a little bit the design. So this is the fun project until here, and it took me exactly 1 hour and 3 minutes to work on it, because I can watch my movie timer. And I actually started a little bit earlier, maybe 1 hour, 1 hour and a half, maybe, because I put this, and this when I started. Now I will take a break, a pause, and I'll come to it later. The idea was to make a bridge, hopefully not to touch these positive lines that I'm having here. All right, and I didn't film, unfortunately, when I mounted the resistors, which are here. You can barely see them probably. This one, this one, this one, and this. I have a zero link resistor like this 01 you see here, and here is actually an LED that got crashed or cracked and transformed itself into a single into a single link. So that's actually an LED there, but it's not functioning whatsoever. It's only a single continuous wire, pretty much. Something welded inside it probably. I don't know what happened, but it transformed itself into a wire, and it's just a 0 ohms link. The same here. I didn't film this part when I mounted the resistors because I was very sure I will have to test everything, and actually what I ended up was using this test nodes that I'm having here, pretty much 800 ohms, 690 probably is there, or 680 ohms there, 560 and 470 ohms for these temperatures there. When I mounted everything, I realized that I made a mistake. This is how I'm actually using, because this is on the other side and I'm using a little mirror here to watch the LEDs if they are lighting on. And right now, as you can see, it is powered actually at 5 volts there, but no LED is on because right now it is functioning correctly. But when I first put the resistors, all the LEDs were on, which it shouldn't happen like that. This is the actual circuit that I used here. So instead of those voltages that you are seeing there, instead of this voltage here on the positive and here on the positive inputs, I'm having this voltage dividers that you are seeing there. So this is the circuit here, and I realized that I made a mistake here. I made a mistake in the 3D environment when I was designing this board. I didn't actually put the values, the resistor values in there. I just slapped 1 kilo resistor everywhere, if I remember right. And I missed some details, and those details cost me this big error that I had originally. And then I realized this wire should be a little bit longer here, and all the wires actually, all these wires were here, but now they are one pad over, like there, and there. Instead, originally it was here, there, and there. And also the 1 kilo, I made this was actually the starting mistake. I put the 1 kilo here, while in my tests. Actually, I have it noted here. You see 1 kilo is on negative and the other resistor is on positive. And between them, I'm dragging the wire to the positive input of the comparator there. So that's so I put basically this is the positive line here and on this other side as well. That's also the positive. This bigger band is the positive, and I put 1 kilo directly on positive, while I should have put it on negative. And here is the negative line on the margin. So I swapped. I took out the 1 kilo that I put it originally everywhere there, and I switched it here on this side where it is correct on the negative. And also when I looked, and it still didn't work like that when the wire it was here. And then I realized, I'm making another big mistake, because swapping that is changing all the logic. So I had to change this those two resistors that were here. I had to move the wire pretty much, to elongate the wires, and I barely could reach that pad, unfortunately. Usually, as you can see, I'm using very long wire specifically for specifically for bending and for dragging, when it's dragging purposes. When I'm bending this thing and it's dragging, not to have too shorter wire. No, it's good to leave a tolerance always. But for this line here, I didn't leave too much tolerance, it's touching there, but it's right on the corner. And here I actually took them out from its pins, this wire here, that wire, all the wires, the signal wires I mean, and I dragged them a little bit like that towards the margin of the pin, and I kind of linked them right on the margin. So that millimeter helped me to reach some points of the next pads. So that was an error I made, and now I corrected it, and you cannot even see because of the light. That's the sensor there. Those are both sensors. So the idea is to correct your mistakes. Okay. I was saying about correcting your mistakes. That light was too bright. Now is in the morning here, and that was the sunlight, very bright. So the idea is to correct your mistakes and push it through, because no one else will push it for you if you don't push it yourself. And this is a life lesson, not applicable only for electronics, but for everything basically. So I made two mistakes actually, one after another, and it didn't work two times. And looking more carefully on the circuit, I really solved it. And now it's working actually. So now it's working correctly. If I'm touching this, it will raise. You see? it will raise to 30 degrees Celsius. Let me actually power this guy here. And right now you will see it's 29.3, and these sensors, I have two sensors here. This diode-like thermistor, and this other blob one, which this blob one is from this device here, from my digital thermometer. And right now it's 28.6. It's slightly below 30. And when I'm touching, you see? Well, I have to touch them in the same time. So you see, that's the 30 limit. Yeah, it's responding something. It's cooling very slowly, and probably it's the same for this thermistor as well. If I'm touching it, you see? Yeah, you see it's gradually letting on. So let me actually do the actual test with my power supply here, with my heating resistor that I'm having. So like I did before, this circuit is not the best. By far is not the best, but it is working. After having a lot of problems with other circuits, so I tried other circuits to make it way more precise than what I'm having here. Here I'm having that shifting problem that I'm mentioning all the time, and you will see it probably also. It's not really responding correctly to 30, 40, 50, and 60 as I want. To some values, to 30 and 40, I believe it is responding correctly, but for 50 and 60 is not. Let's say it's not calibrated correctly yet. Maybe if I'm changing a little bit of some resistors there, maybe I can tweak it to respond more correctly in the future. But until then, I will show you that the LEDs will lit up one after another, but it will not correspond exactly to my 30, 40, 50, 60 degrees that I planned originally. Like I said, only the first two will work correctly. 30 and 40, I believe. So right now, let's make the test. So I'm plugging it in. This light comes up. Hopefully, I can film everything. And yeah, so that's 29 and 30 should be light up, or very around 30 is like that. No, you correctly? It takes some time. As you see, yeah, 35-ish, but actually it's around 30. It's very, yeah, now to 40. Actually, I had very good results the last test that I did, but not right now. 42-ish, 43-ish. Like I'm saying, it is shifting back and forward. It's not a very precise thermometer, but it is giving. So now it's 50. Now this is fucked up. Oh, this is actually spot on right now, but it wasn't before. So I'm having these three LEDs for 50, and the fourth one, the last time I had it, the last experiment I had it on 55 or something, and now it's all, yeah, it's 60. So it's, let me close this because it's and when I'm letting it cool off, 60, 50, now 50, 41. So yeah, it's not perfect by any meaning, but it's a shame it didn't work. Let me blow some cool air. Yeah, on the 30 is very slow cooling here. Yeah, finally. And probably my, you see, when I'm touching it, the heat of my finger is actually increasing quite quickly, because it's a small difference. Right now it's about 28, 29 degrees ambient. So it's, my body temperature is 36 probably, or 34 degrees Celsius. And it is heating up very quickly. And this is a good transition here. I like it. I like the 31 and also the 40. Although it didn't give me good results right now. Let's test it again. Yeah, it's jumping. No, it's jumping. When it's jumping like this, it's kind of working. But you see, on the 60, it didn't lit up. Although it's 50 now, 56. But it's kind of low. You see, it's kind of low. All right. So yeah, it's not perfect by any means, but it is telling the story. It is telling that it is reaching a certain step of temperature. I should tweak it probably a little bit more than it is right now, but by any means it is a workable thermometer what I'm having here, and possibly it can be used actually, but it's kind of not that precise. It's only flow, and it's only problem, it's precision, but it's very imprecise, extremely imprecise. But if you don't care about precision too much, like I care, just to get some yeah, see, just to get some response, a little bit of response, and to warning you, to get some warning. The idea for this device, for this thermometer that I'm building here, is to actually use it for components, to test components, and to put my sensor on the component, glue it there somehow, and while I'm doing my experiments, this will signal me if something is happening there, without me checking it all the time, and without using this thermometer that I'm having here. Usually I am using it, but I thought it's a good idea to have another one. But this is way more uncalibrated and shitty, very shitty one. For a very general use, probably it's good enough, very general, but not for precision in any means. But I'm happy because I'm happy it's working right now. Although I had a lot of
errors and a lot of problems with it to build it, and I'm still having them because this was from design, from the very first test. It didn't work correctly. I did had this shifting problem, and I was aware. Actually, this is my first ever thermometer that I'm making right now. It's very shitty thermometer, but it is leaving room for the future to build better ones. I hope I will come back to this type of projects with thermometers and make way more better than what I'm having here, this shitty one. My little shitty one. But yeah, it's working. It's working, and I'm happy that it is working. As it is, shitty as it is working, you see? Yeah. Alright, thank you very much for watching. I hope you liked my progress and my building. Because this is another point that I wanted to show you, the way that I build things, and I hope you like it. I hope you like this kind of building projects that I'm making, at least. Alright, that's it. Thank you very much, and goodbye from your favorite artist electronics, Mr. Kitov.